All right, today we're going to be talking about the probability of things happening. For example, if you know that there's 40% chance it's going to rain, what's the percent chance it's not going to rain? So working your ways around these probabilities. So earlier in class we talked about this, what those numbers mean, and what numbers can we put to these probabilities, and we discussed what does the 0, what does the 1 mean? Something's impossible, something's certain to happen, and then all the probabilities in between tell how likely it is to happen. So in this next example, we're going to use a game called Go Fish, and Mike's playing Go Fish, and he wants to win a giant stuffed animal, or he could win a smaller stuffed animal or a plastic kazoo. You can tell the giant stuffed animal is the grand prize. So here's the setup of what his tank looks like. You have 1 green fish, 3 blue fish, and 6 yellow fish. So we're going to just investigate this kind of deeply today. So this is lesson 121, 1.2.1 in the book, and problem number 51. The game is called Go Fish. Okay, so let's write what the tank setup was. We have 1 green fish, we have 3 blue fish, and we have 6 yellow fish. Alright, so here are the numbers that we're dealing with, 1, 3, and 6. And we know that the grand prize is, if he gets a green fish, he's going to win the giant stuffed animal. So the giant prize, and we can kind of look at, well, why is that green fish the grand prize? Okay, so that's for the giant stuffed animal. Now, if every fish in the tank was green, it's not set up like this, but every fish was green, how would you describe the probability of Mike winning a giant stuffed animal? Okay, so this is question A. Okay, so if all fish are green, if all are green, what is the probability of winning? Okay, now if all of them were green, there'd be nothing but green to get, so he's pretty much certain to get green. And if we're talking about certainty, okay, just remember the probability of green, we write it like this. P means probability, and then in parentheses is what we're looking for to happen. Okay, and this is going to be 100% going to happen because it's certain. It's certain to happen that you're going to get a green fish if all of them were green. So that's that 1 that we saw in that number line. Now, the way it's set up now, if you look at the tank, that's how it's set up. What would be the probability that Mike gets a blackfish? Okay, so this is question B. What is the probability that the fish is going to be black? And since there are no fish that are black in the tank, that means that it is pretty much impossible to get a black fish, right? So since there are no black fish, that means that the probability is 0. Okay, it is impossible to get. All right, question C. Given the information here, what is the probability, or what percent of the time should Mike expect to catch a green fish and win the giant stuffed animal? So the percent of the time is the same thing as probability. So they're pretty much asking, what is the probability that he is actually going to get a green fish? All right, and when you look at the tank, you can see that there are 10 fish total, and only 1 of them is green. So that means that since there's 1 green out of 10 fish total, that means that the probability of getting a green is 1 out of 10, because there's only one. Now, as a percent, this is the same thing as 10%. We worked on our conversions a little earlier last week. Okay. Now, what this actually means is if we were to play this game 10 times, that means fish 10 times in this tank, and catch something and put it back, we would expect to get a green once. If we play 10 times, okay, that's where that 10 total comes in, we should expect one green. Right? And that's pretty much what probability means, right? If probability of getting this is just how many are there out of how many, right? And we play it 10 times, we do have a chance of getting that green once. Might we get it more? Sure, we might. Okay, so let's go to the next one. So this is the probability, how it's set up. Now this basically says if he gets a fish 10% of the time, a green fish 10% of the time, that means 1 out of 10. The desired outcome would be the green fish, that's how many there are, and the possible outcomes is 10, how many times he's going to get it. So number 52 in the book is asking, what is the probability that he is going to catch a blue fish? The way this is set up, what is the probability of getting a blue fish? And since there are 3 of them, that means the probability is 3 out of 10. There's 3 blue fish, there's 10 total fish. Desired outcome, total possible outcome. And this would be 30%. And what is the probability of getting a yellow fish? All right, and a yellow fish, we can just look at the numbers here. Well, there's 6 yellows, so that means the probability would be 6 yellow fish out of 10 possible fish. So that would be a 60% chance. Now, keep in mind that these are only theoretical probabilities. That means that this is what should happen. That doesn't mean that's absolutely going to happen. You can play 10 times and get 10 yellow fish. That doesn't mean that's a 100% chance of getting a yellow fish. So theoretical means what should happen. Okay, and we're going to highlight should because it doesn't necessarily mean that that is going to happen. Okay? All right. So I'm going to come back here and also highlight this important point that 1 out of 10 means if we play 10 times, we should expect to get 1 green. Because I'm going to highlight that point pretty often throughout the year. That's what probability means. If we were to play it that many times, that's what we should expect to get. Okay, now on this next part, it says probabilities are theoretical, and if we want to find out what is more likely to happen, let's look at where these would fall on that number line that we drew earlier at the beginning of class. Okay, this is number, okay, so this is B on this one. So if we were to draw that number line, let's see, we'll draw it from here to here. And remember that this is 0 and this is 1, and 0 means impossible, and 1 means that it is certain to happen. Okay, so where would green fall? So if we know that green is 10%, 10%, see here's, this would be 50%, so 10% would be somewhere around here. So this is green. where would yellow fall? Okay, so yellow is 60%, so that's 50%. 60% would be somewhere here. And then blue would be 30%, so we just basically cut this. 30% would be approximately here for blue. That's almost a third of the way. Okay, now this kind of tells us which is more likely, because if it's closer to the certain, then it's more likely. If it's closer to impossible, it's less likely. So which one of these is the most likely? Most likely is yellow. And then the least likely is green. And we can also look at the percentages. 10% is less than 30%. 60 is more than 30 to tell about that likelihood. All right, now for this next one, you have a spinner that you're going to create. And on this spinner, 40% of that spinner should be red, 1/10 should be yellow, 30% should be blue, and the rest should be green. So you're going to first draw the spinner. What do you think that spinner looks like? And then answer which is most likely, which is least likely. Okay, so let's first set that up. This is problem number 54. And we're talking about a spinner, which is 40% red and 1/10 yellow and 30% blue and the rest green. Okay, now let's go ahead and draw the spinner. What do you think this spinner looks like? Okay, and firstly we ask ourselves how many sections are going to be in this spinner to accurately draw this spinner to show equal portions. Okay, so you should have figured that we need 10 sections because this is 1/10 yellow, and all of these can be shown in tenths. So we kind of draw it kind of like a star. Here's the arms, like a starfish. Okay, so kind of like the arms and the legs of a starfish. And then those would be fifths because we broke them into 5 parts. Now those aren't exactly fifths, but it's close. Okay, so now we have 10 parts. We broke those fifths in half. And now, if it's 40% red, how many of these are red? We have 4. 1/10 yellow, so that means 1 of them. 30% blue, that means 3 of these are blue, that's 3/10. And then the rest are green, so that means we have 2 greens. Now, which one is the least likely to happen? And you see that it's yellow. There's only 1 yellow. Okay, that's 1/10 probability that we're going to get yellow. Which is the most likely? And since there are 4 reds, more than any other, we know that red is the most probable, which is 4/10. Okay, or we can look at the percents. That's 10%, and this is 40%.